The law of conservation of momentum is often used in combination with the law of conservation of energy, or more specifically, mechanical energy. You will remember that the law of conservation of energy states that the total energy in a system cannot be created or destroyed, only transformed from one form to another. Now, mechanical energy, commonly known as EMEC or EM, is the sum of an object's gravitational potential energy and its kinetic energy. A reminder that the formula for EP, or gravitational potential energy, is mass times g times its height. And because gravitational potential energy can only exist in an object if the object is above the ground, and its kinetic energy is half its mass times velocity squared. So the principle of conservation of mechanical energy states that in the absence of air resistance or any external forces, which is most commonly friction, the mechanical energy of an object is constant. That means its sum of its potential and kinetic energy initially is equal to the sum of its potential and kinetic energy finally. And this is most often applied to a situation where something is falling from a height to the ground, like a roller coaster, or falling or rising from the ground to a height. So I've given you a worksheet of combo questions, energy and momentum, and we're going to do number 1 as a worked example. So number 1.1, it says state the law of conservation of energy. Well, this is an old worksheet, so you would be most likely be asked the principle of EMEC to state that, which would be obviously that in the absence of air resistance or any external forces, the mechanical energy of an object is constant. Then for number 1.2, it says use the law to calculate the speed of the bullet block combination immediately after the collision. Now, the bullet, we have been told, is mass 10 grams. So 10 grams must be converted to kilograms, 0.01 kilograms. It's fired horizontally into a block of wood of mass 2.49 kilograms, suspended by a string. The bullet block combination. So the combo equals 0.01, which is the bullet, plus 2.49, which is the block. So the combo has a total mass of 2.5 kilograms. And we are told it rises to a vertical height of 32 millimeters after the collision. 32 millimeters must be converted to 0.032 meters. Right, let's begin. So we're going to say that EP plus EK initial equals EP plus EK final. Now, the bullet initially, or the bullet block combination initially, had no potential energy, 0, because it was at ground level. But it did have kinetic energy. Half mv squared, half the mass is 1.25. We don't know the velocity, we are asked to calculate that. Now, it did rise to a height of 0.032 meters, so it did have potential energy. So the combo mass is 2.5 times by g, 9.8, times by 0.032. That is its potential energy that you just calculated. But because it rises and stops, it has no kinetic energy, because remember, kinetic energy is velocity, half mass times velocity squared. So if it stops, it has 0 kinetic energy. Right, so doing this sum, we get 1.25 v squared equals 0.784. Therefore, v equals the square root of 0.784 divided by 1,25, and we get an answer of 0,79 meters second to the minus 1. Right, so that's the speed of the bullet block combination immediately after the collision. Right, let's look at 1.3. 1.3 wants you to state the law of conservation of momentum, which you know that momentum linear, the total linear momentum of an isolated system remains constant. And then 1.4 says to you, calculate the initial speed of the bullet just before it hit the block of wood. Now, if you are asked to state the law of conservation of momentum, that is a clue that you're going to use that in the next question. So we've got to say P before equals P after. Right, so the mass of the bullet is 0,01. You've been asked to calculate its velocity. You don't know that. But the block was stationary, and if it's stationary, it has no momentum. So afterwards, the bullet and the block stick together, and they have a velocity of 0,79 meters second to the minus 1. You have just calculated that. Right, to do this sum, we will see that we've got 0,01 times by the initial here on this side equals 2,5 times 0,79, and once we have done that sum, we work out that the initial velocity is 197,5 meters second to the minus 1. Right, so I've showed you how the law of conservation of mechanical energy and the law of conservation of momentum are often put together in one problem. Now you can try number 2 and 3 yourselves.